Okay, so I'm here on the Master in Astronomy, and I want to go to the textbook because I want to tell you a little bit about what the course is about. So if I click over here, it will open now this e-text, and we can now take a look. This is the textbook that you're using. I think this is actually a pretty cool textbook. So you can have, there are like different chapters over here. The first part is the developing perspective, and this is going from the modern view to kind of a more historical overview. In the summer course, we're going to skip chapters 2 and 3 just because if I teach all of this that I would otherwise teach in the 16-week course, you're just going to be overwhelmed, and I think it will be hard to keep up. So the first chapter over here is the first 5 days of our course, and you will be learning a little bit about our current understanding of the universe and the current pictures that we have of the universe. So the scale of the universe, the sizes, how we fit in the big picture, the history of the universe, and then just like the earth in relationship to everything else. Okay, we will skip chapters 2 and 3, but then we will come to these key concepts for astronomy. My goal, I guess, in this like short semester is for you to really understand to a certain extent how much we can do in 8 weeks. How do we learn about the universe? How do astronomers know what they know? Because it's actually quite amazing to think to what scales we probe the universe without basically ever, you know, going anywhere but to the moon. Okay, and so the chapter 4 gives you the background about basically some physics that you need to know, and mostly what you really need to understand is like how gravity works. Okay, and so the focus over here will be for us understanding the gravity itself, so that we can understand why do we feel comfortable on the earth and we would not feel comfortable close to the black hole or like white dwarf or neutron star. So how does gravity really work? How does it depend on the mass, and then how far you are from the object? That will be the key here to learn. Okay, but you will learn a little bit more about the motion, some conservation laws, and the energy itself. This is also general ed course, so if you forgot some of these things that you learned in high school or like middle school, it will be a good refresher. And some of the animations that you have, some resources that you have through Mastering Astronomy are pretty cool. Then the next thing is actually the light, the chapter about light. This is very important because actually light is a messenger that brings all of the information to us. We build telescopes, as you know, we collect the light, and then we analyze the light to learn everything that we know about the universe. And what I mean by that is like, compositions of the stars, and how fast things are moving from us. You know that we live in the expanding universe, which means everything moves away from us. So how do we actually measure those speeds of the objects away from us? And then also we can learn about the temperatures of objects. All of that by basically analyzing the light. All of that by passing the light through the prism, if you wish. And so here is that important physics of how light and matter interact. And we will be done with all of this basically in less than 2 weeks. That's the goal. Okay, so these 3 chapters in 2 weeks. Okay, after that, when you have this physical background, we will go and learn about the other worlds. So we will start talking about the formation of the solar system. I like this chapter. I think really the physics over here of the formation of the solar system tells you this story, that like this layout that we have in our solar system, that the small rocky planets close to star, and then the bigger giant planets further out from the sun, that is really caused by the temperature distribution in the early solar nebula when the planets were forming. And so since that physics is always going to be the same from star to star, we expect all the solar system to have exactly the same layout as ours. But as we now actually discovered, and that is the chapter 10 over here, we discovered more planets outside of our solar system, so extrasolar planets. We have seen that that's not actually the case. Even though they should look like our solar system, small rocky planets close to the star and the bigger ones further out, they don't. And so all of these discoveries that we have about the planets outside of the solar system, and the first one was only discovered like literally 20 years ago, 25 years ago, they teach us that there's some perturbations or instabilities in the solar systems that can happen and change this layout expected based on the physics. So after we learn about our solar system, after we learn about the planets outside of the solar system, we will then step out and talk about the sun. This is also one of my favorite lectures. Actually, the sun is very, very powerful, and can quite influence the life on the earth, and especially now our dependence on the satellites and on the electricity. So we will learn about sun, how sun actually produces the energy that is essential to life on earth, and that will also apply to all of the other stars. And so that will be now a good intro to studying other stars and their properties and maybe some patterns that we can see. Their star clusters. Some of my favorite objects in the universe are globular clusters. So there are two types of clusters. One are open, the other ones are globulars. So we learn about them as well. And then these two chapters, Star Stuff and the Bizarre Stellar Graveyards, they're actually about life and death of the stars. And so as you can see, we will talk about low mass and high mass stars. The low mass stars are stars that will have similar life like our sun. So basically, they will end up as white dwarfs, while these high mass stars, they have very violent deaths through supernovae explosions, and they leave behind white dwarfs and black holes. And so we will then learn what kind of a cool stuff can happen if two, like, stars, one nearing the death and then the other one, like, kind of in the bold phase, are close to each other, what can happen over there in those systems. And then finally, this chapter over here is about some most extreme physics objects that we have in the universe, and those are the white dwarfs, neutron stars, and black holes. All of them are actually remnants of the stellar life. And then we'll study some extreme events over here. After that, we step out and we learn about the galaxy. The galaxy is the assembly of stars and gas and dust, and most of everything, actually, it is the dark matter that dominates the galaxy. So we'll talk about the Milky Way galaxy, and then again we'll expand this and talk about like the other galaxies that we see in the universe and how galaxies change throughout the evolution of the universe. Okay, so the galaxies, as we look at galaxies now around us, and then the galaxies in the early universe, we can see that there are some changes in the patterns, how galaxies look like, how many stars are produced in galaxies, and so on. And then we will have this very interesting chapter about the birth of the universe, a lot of physics that it's hard for everyone to understand, okay? But we'll kind of just like overview this, and we will finish by talking about the dark matter, dark energy, two ingredients, let's say, that dominate the content of the universe. And so basically, what will be the fate of this, like, accelerated expansion universe? And so that is the course. It's a very, very interesting course, I think. And you can see, even when we do this in 16 weeks, it's very, like, engaging. Every single week we have different topic. And in this, like, online class, we'll have to go a little bit faster. We'll have to, like, maybe have 5 days per chapter instead of having 7 days. And we'll have to cut some topics out. But it should keep you, I think, informed and very kind of engaged, if this is something that you like learning about. So once again, I hope you will enjoy class, and this should help you build expectation of what is coming up and what the class is about.